This is Dr. Holt. I want to go over relative motion and show you a quick video on how to solve that. We're going to take a problem here. Move this up so you can see that. And this one I have John. He's traveling 30 meters a second and an angle of 28 degrees. So John's going off this direction, 30 meters a second, 28 degrees. Sarah is traveling 40 meters per second at an angle of 47 degrees. So Sarah's going back this direction at 40 meters a second. Angle is 47. We want to find out what is John's velocity. So what is John's velocity in respect to Sarah? I'm going to show you how to set that up. Okay, what you want to do with a problem like this first is to find out what the horizontal and the vertical components are for both the velocities. So I'm going to do the velocity of John in respect to the x-axis. So if I'm going to do that, that's going to be 30 times the cosine of 28 degrees. When I run that, that's going to give me positive 26.5 meters a second. So John's velocity in the x direction is going to be that. Now I'll do the y. The velocity of John in respect to the y will be 30 times the sine of 28. And when I get that, I'll get 14.08 meters a second, and it's in that direction. Alright, now we're going to do the same thing for Sarah. The velocity of Sarah in the x direction. Now this one's going to be minus 40 times the cosine of 47. And the reason it's going to be minus is because the x component of this is going to be going off to the left. When we run that, we will get 27.28. And we can make it negative, or you can go ahead and show the vector going this direction. Either one's fine. Now we'll find the velocity of Sarah in respect to the y. When we do that, we will do 40 times the sine of 47, because the y component obviously is going up, head up to this direction. We'll run that and we will get a velocity of 29.25. Okay, and we'll show a vector going up. Alright, now this is really the easy part. We're going to find out what the velocity now of John's velocity is relative to Sarah. So we write this as what is the velocity of John in respect to Sarah, and we're going to do the x component first. So if I'm going to do that, I'm going to go ahead and write out whatever's on top, John's. We put the velocity of John first. So we know that it's going to be 26.5. Okay, you immediately subtract. So you're going to subtract, and now you're going to subtract Sarah's velocity in the x direction. Now Sarah's going 27.28 to the left, or going negative, but we leave the negative in there. And we do 27.28. We subtract that, and when we do that, we basically add. Those negatives cancel out. That gives me 53.72 positive. I'm going to the right. So that's the relative velocity of John in respect to Sarah along the x-axis. Now we're going to do the same thing. Move this out of the way. We're going to do the same thing, and we're going to do it about the y. So the velocity of John in respect to Sarah in the y direction. Okay, first thing I do is I find John's velocity. It's going to be 14.08. Again, I go back and subtract immediately. I'm going to subtract Sarah's y velocity, which is 29.25. When I do that, I will get a minus 15.17. So I'll draw the vector. I'm going down. Alright, now what you want to do is you go ahead and draw these vectors. Just make yourself a little sketch. So we know we're going over this way. 53.72. We're going to start from here. And remember, when you add vectors, you go from head to tail. So we come down and we're going to go 15.17. Now we need to find this hypotenuse. That's going to give me my resultant velocity. So that's really what the velocity of John is in respect to Sarah. That's our hypotenuse. So what we're going to do is Pythagorean theorem. We're going to do 15.17 squared plus 53.72 squared. We're going to take the square root of that. That's going to give me this velocity right here. When we run that, we will get a value of about 55.82. So 55.82 meters a second is the velocity of John in respect to Sarah. Now if we want to find the angle here, theta, the only thing we have to do is take the inverse tangent of the opposite over the adjacent. So if I take the inverse tangent of 15.17 divided by 53.72, you will find out that this angle theta is 15.77 degrees. And that's all there is to it. It's very straightforward. All you have to do is follow a methodical approach, and you shouldn't have any trouble with these type of problems. Best of luck with these problems.